Hello there. In this class we are going to continue our discussion from the complements now. First of all, let's try to understand what's the need of these complements. So if you're dealing with unsigned numbers, so in that case you are not going to be familiar with complements at all. But if you are somehow interacting with signed numbers, and by signed numbers I'm specifically referring to negative numbers. If you're trying to make your computer represent some negative numbers, in that case you are going to be needing such kind of complements. Now whenever you are studying any book in DLD and you see the word complement, there are going to be two categories of complements. One is what we call R's complement and the other one is what we call R minus 1's complement. So what do we mean by R? The R means radix, and radix normally refers to the base that we have normally with a number. Let's say I have 101 here. This is a binary number. We can see that by identifying its base. So this base is also called as radix. So we will operate on this base or this radix to find out the complements of these. So if we now, as I discussed, we are going to be having two type of complements. One is going to be R's complement and one is going to be R minus 1's complement. Now if you are a little bit familiar with complements, you might have heard of complements like 10's complement, 2's complements, 9's complements, 1's complements. So these have been grouped into R's and R minus 1's complements. The 10's complements and 2's complements these come in the category of R's complement, and 9's complement and 1's complement, these come in the category of R minus 1's complement. So now how do we find out the complement of a number, and when do we use 10's complement and when do we use 2's complement? Now if we are trying to deal with decimal numbers, we are going to be having two options. We can either use 10's complement to find out the complement of the number, or we can use 9's complement to find out the complement of that number. But if we are trying to deal with binary numbers, in that case we will have 2's complements or 1's complement to find out the binary of these number. Now there is going to be a basic formula that we are going to be discussing in all this chapter. That formula for R's complement will look like somehow this, and for R minus 1's complement this will look like this. Simply this is the R's complement. This is the R's complements formula, R power n minus n. I will tell you what these things mean, and if you simply put R power n minus 1 instead of this place, we will get R power n minus 1 minus n, which is going to be the R minus 1's complement for us. So R minus 1 is also called as diminished radix complement for us. Okay, now let's try to see the formula R power n minus n. What is this R? I've tried to write this down here. R is going to be the radix, or we can also call this is the base. If you have a number that you want to find out complement of that number, you will see the basis. This R will be the base of that number. N is the number of digits. If you are given a number, definitely the number is comprising of some digits, so this n is the number of digits that you have, and this capital N is going to be the actual number. This is the number that you have in front of you, which you want to find out the complement of this number. So this is the actual number. Now I don't think you will get it like this, so I'll jump towards the examples. So let's find out some R's complements of some numbers. If you have been given any number like this, let's say I've been given this number here, which is of the base 10. So this means that I can either use 10's complement or I can use 9's complement, but currently I'm discussing R's complement. It means I'm going to be using 10's complement. So here it is, the formula that I'm going to use. This is the R meant base, so I'm going to write the base here. This is the n means the number of digits, so I have got 5 digits here, so I'm going to write 5 in the exponent, then I have minus here, and then I have n. The capital N means the number itself, so the number itself is 52520. Now what do I need to do? I need to find out this. I think this becomes like some 1 lakh, I think, and I will subtract this from this number, I think, which results to a number that is going to be 47,480. I think I have pre-calculated it, so I have memorized it. So this is going to be the 10's complement of this number, or we can also say that this is going to be the r's complement of this number. But if we are dealing with binary numbers, in that case the formula will remain the same. We'll simply do some sort of adjustments here. The r is going to be definitely 2 here because we are dealing with binary numbers. The n is going to be the number of digits. In this case I have got 6 numbers here, and the minus will remain on its place. N is going to be the actual number that I have, so I have 101100 here. Now what do I need to do? I need to find out 2 power 6. 2 power 6 I think become 32, 64. 64 minus 101100. Now you need to know that this number is in decimal, this number is in binary, so there is no way that I can make a subtraction here. I can perform a subtraction, so I need to convert this one. Either I need to convert this one into binary, or I need to convert this one into decimal. So it would be simple if I will try to convert this one into binary. So I think by converting it into binary it becomes somehow like this. So if I perform a subtraction of these numbers, I think I'm going to find out 010 100. I think this is going to be the complement of this number. This is going to be the 2's complement, or I can say r's complement of this number. So this is how you find out the complements of numbers. But if you are dealing with r minus 1's complement, these are again some options for you if you want to try these out. Now if you are going to find out the 9's complement of a number, this is the 9's complement, because I am discussing 10's complement, but I am also discussing r minus 1's complement. So if we have a number here, this is the same number that we dealt with in the previous slide. So if we have this number here, the formula is going to be a little bit modified here. R is the same here. R is going to be 10. N is going to be the same here. I have got 5 digits here. Minus 1. The parentheses are closed now, and minus 52520. So if I try to evaluate this one, this is going to be 10 power 5 is going to be, I think, 1 lakh, and 1 lakh minus 1 is going to be 99,999. So if I subtract this number from this number, I think I'm going to get some number like this. So this is going to be the 9's complement, or r minus 1's complement of this number. Just like that, if I'm trying to deal with binary numbers, the formula will still remain the same. I'll do some small adjustments. 2 power n is going to be 6 minus 1, and I'm going to have minus 101100 here. Now what am I going to do? 2 power 6 is going to be 64. 64 minus 1 becomes 63. So I need to subtract 63 from this number. So I can't do subtraction just like that. So I need to first convert this into binary. So this becomes this in binary, and this will stay the same. If I convert this, it's going to be 110010. So this is going to be the result of this subtraction. So this is going to be the 1's complement of this number, or I can also say that this is going to be r minus 1's complement of this number. So this is how you can perform complements in DLD. If you have a negative number, you can use one of these techniques. If you have decimal number, you can use a 10's complement and 9's complement. And if you have binary numbers, you have the option to use 1's complement and 2's complement. In this course we are going to be focusing on 2's complement. So in the next class we will thoroughly discuss 2's complement. Thank you.